Alrighty, boys and girls, this is going to be fun. All right, so we are going to do depth first search over this adjacency list iteratively. Okay, let's get into it. So I'm going to go here, make sure I'm in the right. I don't like how that's broken out. All right, cool. So let's do DFS. I'll say iterative. Cool. Hopefully I spelled iteratively right. And then we want to give it a starting vertex. So I'm just going to run that as start. And then at the end of the day, we want a list of everything that we visited. So we'll call that the results, which obviously doesn't exist yet. So let's go up and create it. So let's do a const results equals an empty array. Okay, and then we also need a stack data structures, which we can just do with an array in JavaScript. So const stack is equal to an empty array. But since we already have one of the items, one of the vertices that we're starting with, we can just default it in here like so. It's diak stack. We're also going to need to know to keep track of what we visited so far. So we can create a data structure for that, either an array or a map or an object. So I'm going to go with, first of all, the variable name, which is visited. And we'll start that off with just a regular old dictionary. Cool. First things first, we have, since we're starting at start, we have visited start. So I'm going to set visited of start to equal true. Sick. And then after that, I want to create something to mark out which vertice we're on when we're looping through stuff, because we're going to have to loop through all of them somehow to populate that results array. So first things first, I'm just going to create a variable called current vertex. That should do. Not going to use it yet because I am going to come down here and say a while loop. I want to use a while loop until we're done, and we're going to manage when we're done and with the state or the length of the stack. So make sure everything is on. Cool. All right. So we can do. Let's see. While stack dot length is greater than 0, or since it's 0 is falsy and 1 is not, we can just do that. We want to do a couple of things. What do we want to do, Jeremiah? So we want to pop off the current, pop from stack, and then what we pop will go into results. Push results. Cool. Sweet. So that's where this current vertex is going to come in handy. We're going to do current vertex is going to be equal to, what do we call it? Stack dot pop. Sick. Okay, now we have a concept of current vertex. It's popped off, and now next line of pseudocode is what we pop. We're going to push into results. So results dot push current vertex. Current vertex. Oh, cool. Cool. We're almost there. And then now we want to look at this adjacency matrix, and for each, let's see, for each connection, for each neighbor, we want to put that into the stack and then pop it out into the results, essentially. Okay, so let's do that. This dot adjacency, holy smokes. That's a long word. This dot adjacency list. From adjacency list, where are we at? We are at current vertice, current vertex. Cool. And that's going to give me a resulting array of all of the connections at that current vertice. So since it's an array, I can do for each to iterate over each item. So dot for each neighbor, we'll call it neighbor. We're going to do something conditionally. So only if it hasn't been visited. So visited at neighbor. So only if this neighbor hasn't already been visited, it's not in the visited object, then we're gonna do some stuff. And that stuff is, let's see if I think I'm missing something here. I'm not. Okay, so that stuff is, first of all, set it to true because we're gonna visit it, mark it off the list. So visited at neighbor is going to be equal to true. You could use an array here, but for visited, but I'm gonna use an object just for constant time lookup if I ever need it. And then as we're visiting them, we're going to push them onto the stack. So stack dot push the neighbor. And then oh, what is happening down here? No, we don't want to set the results to an empty array, silly goose. We want to return results. So if I did that right, and we call, first off, let's just look at G real quick, the adjacency list, noise, and then if we call G dot, what do I call it, the method? Iterative DFS, and then pass in where we want to start. Let's start at the alpha. We should get everything. Can't access stack before initialization. I bet you said that. Oh, that's supposed to be start. Why didn't y'all tell me? So now we have A, C, E, F, D, and B. And let's see if I have the visualization anywhere. I do, and I'll post it here. And the reason that it printed out this way, excuse me, actually can't see the print. Cool. The reason that it printed out this way because it hit the neighbors first, so it went from, can you see my mouse? You cannot. Move it on up. And you can't see the output either. Perfect. All right, the output is this. Boom, you can see that. The reason it printed out this way because it's depth first search, which basically just means we're going to the neighbors, as deep into the neighbors as we possibly can. So it's gonna go A to C to E to F to D to B, because they're all technically neighbors, and it's going to its first neighbor first, as in depth. All right, that's gonna do it for depth first search iteratively on graphs.